and how they are exploited as a vulnerability. Based on that, we recognize the issues and how to set the countermeasures or the solutions. Because it's not the purpose to know the issue only. We have to know the issue, the weakness, the limitation, and on top of that, we have to suggest or we implement a solution for that to secure all what it concerns the network security. We start at the level of securing your means of authentication towards all the services on a network, actually, which is a very weak security approach, which is the password-based authentication mechanism. With suggestions to implement, to use actually, and to let's say approach the authentication mechanism based on the password usage. Suggestions here to use a hard password to, let's say, to fail attacks against password attack techniques. Okay, we continue. Still in the concern on the on the concern of network vulnerabilities only. This topic here, this slide, what we see in front of us, the topic of default accounts, is one of the very famous security concerns to be tackled by all administrators whenever they are setting a new network environment. All the network devices, I repeat, they are actually equipped with a default account. First of all, what are the network devices? We talk about routers, switches, we talk about servers, we talk about repeaters, we talk about maybe we can actually, it is a network device, but it's not in this regard. They are not related with default accounts. The hubs, all the peripherals, hardware actually responsible for doing work on the network level, mainly to interrelate hosts or to interrelate devices. They are all equipped. I can use this actually, all it is to be underlined. They are equipped with default accounts. What does it mean? Actually, when we say, for example, you are going to get actually, let's take the real example, Omantel or Naurus actually network device to get access to the internet. The modem or the router, you get it at home. What is that? That is a network device. Will they give it to you and tell you go home, you'll use internet? They have to configure it for you. They have to set it, they have to connect it, and they have to give you access. This have to give you access. It is a matter of configuration. It is a matter of adjustment, management of that device only. How and where? Through an account. There is a system controlling that device, and that system have a default account authenticated for all users, actually to be given by, to be actually used by all users within a specific, let's say, using specific credentials for adjustment purposes, for management purposes, control purposes. What does it mean? It means those devices actually, they are not related to Omantel and to Naurus and to you or to me or to he or to she. No, they are set by the manufacturer to be utilized by everybody. The router given to you by Omantel, it is manufactured by Siemens or whatever, D-Link or a company, a network devices specialized company. The authentication mechanism against the account on that router or any other network device, they are standard. You go to UAE, you go to United States, you go to Saudi KSA, wherever you go, they will be actually authenticated using the same credential, the same username and the same password. Because of this, they are said default account. They are actually periculous, and they are a question of a vulnerability issue for the network. So, conclusion: default account is the system that has a standard access or authentication mechanism to be utilized by everybody. We can have different definitions, but this is the shortest, the briefest. The system is generated by the provider, which is the device creator, manufacturer, and to be utilized by everybody. Why? For configuration, for management, to let in, to block, to allow, to deny, and so on. Management. Why they do it? They have to do it like that. And later on, you have to control it. Those default accounts here, see, they are to be deleted after the installation and after the configuration. Those default accounts, they are not to be usually available. They have to be utilized for the first time. Later on, they have to be blocked, deleted, changed. They have to be terminated. Used for the first time, you configure your device, your network, and that's it. You delete them. Delete what? The default accounts, or the default account of that particular device. Due to misconfiguration of the default accounts, this is an example. It is from 2008. Those two guys here, they actually they were successful in managing to access a default account in an ATM machine in a certain distributor in a certain network, financial network, and they were able to configure that default account to manipulate that, let's say, transfer machine to withdraw 20 base bills instead of funds. They ask for 1, the machine gives them 20. They ask for 100, the machine gives them 20 hundreds. You imagine, they ask only $1, the machine gives them $20, and it counts $1 only. So these actually real case, and it was done due to the misconfiguration of the default account. They were actually they were sentenced and they were actually caught. But this is due to the bad configuration of the default account. This is a real case. We continue. Whenever you have any question, you can stop me in between. Also, still in the context of the network issues only, here we're going to present a new topic. Actually, we saw this word. It's not new for us. We saw that in the chapter number 1 when we described the distributed attacks. In the context of the distributed attacks, there is an attacker, one only, and there are machines to act according to the request of the attacker, and there is a victim. The machines, in plural, how they act according to the attacker's wish, because they are compromised. I'm going to ask you later on to redefine me, so please be with me and focus very well. Focus. Those compromised devices, they are acting according to the will of the attacker. How? Is it magic? No, because they are already compromised. And being compromised means the attacker has already injected his virus or his control unit on those compromised devices. And then his malware is controlling each of those devices. The injected malware, mainly it would be called a backdoor. As per literally said here, backdoor, as per the description of the English literature here, backdoor is something, it is in the background, it is to run in the background, means without any hint. The hint here is not to tell the computer owner, hey, I am a backdoor and I'm here. I'm using your computer for your instead of you. No, it will not say that. It is a backdoor. Also, it's not only that it is hidden. It would not ask for permission, the consent to access the computer. It would not be made from the beginning. So no consent, and also in a hidden way. It's a computer program, conclusion, that has accessed the computer without consent, and it is acting in a hidden way. That is specified, or let's say classified or nominated, described to be a backdoor. The main purpose is to help an attacker control that machine. Means it would allow remote access. It would allow remote access. Here it is. It would allow the attacker to access remotely that compromised device. In the sense of this backdoor. It is a malware, yes. It has a payload, yes. And this payload is to allow the remote access mainly. Later on, we will talk about the virus aspect, means it will delete or it will hide or it will do something like that. But the main purpose of a backdoor, since it is a malware, its main role, the main role of its payload is to allow remote access. Remember, the backdoor, it is not to delete files. It is not to hide resources. It is not to share. The backdoor, as a first definition, it is a malware because it accesses without consent and it is acting in an obscure and obfuscated mode to allow remote access. What it comes after, there are other things. Actually, there are prescriptions. Examples of backdoors, actually, we talk about Trojans, and they can be found in even in manufactured devices. Means they are not only computer programs implemented by attackers. They can be also integrated in a hard device. There is a chip actually that has been actually generated with its backdoor to trap users, no more no less, to trap users. Yeah, whatever. For actually, this one was for dedicated activities for military actions and so on. So yes, this is an example of a backdoor to allow remote access to control devices to and so on. Any questions in this regard, please?
No, Mr.
Okay, great. So in the same regard, network vulnerabilities, we describe the privilege escalation also. Later on, also, we are seeing different technical approaches here related to the network vulnerabilities, but they are all correlated. Later on, you'll see that there is a relationship in between all. The privilege escalation here, it's a context that an attacker do refer to it for a purpose, to elevate its rights from a normal user to an administrator's level, let's say. But technically and literally said, privilege escalation is to change the right from a level to another. Means we can change, actually, you as a student, you want to access the EduWave as an instructor. Why? Because you as a student, you can see only your marks when I, as an instructor, open them. You cannot see your marks before I open them for you, because you are a student. But if you access the EduWave as an instructor, you'll be having other options. Why? Because an instructor is an administrator more than the student. So if you reach to change your session from student to an instructor without permission, this is a privilege escalation. This is an example of, this is a case of privilege escalation. Technically, usually an attacker will elevate its right from a normal user to an administrator to a higher level. But changing from a high level, see, I might ask you this question in the common assessments. If an attacker changes the right from an administrator to a normal user, technically, yes, it is a privilege escalation also. But on real plane, none will do that. If you are an administrator, you delete your rights? No, you'll use all of them. You are not going to go to a minimal right level. So if you're an administrator, you do not go to a smaller right, let's say, session. You are I am an instructor, I change myself to be a student. No. I remain administrator to control all. But is it a privilege escalation, this behavior? Answer is true. Yes, it is. We continue. Second part in this unit, which is the categorization of those attacks. Here we define and technical approaches describing network vulnerabilities. Now we are going to classify them into groups, categories. We are going to see the same vulnerabilities, but according to groups, based on groups, categorized. We were talking about the distributed attack and the backdoors, privilege escalation, and so on. Those are the last thing, the last vulnerabilities we described. Denial of service is one of the categories that is classifying all the network attacks that cause service irresponsive or responsiveness, irresponsiveness. What does it mean? Any attack on a network to cause a service not available, it is classified to be a denial of service attack. In the sense of, you are trying to open a website, for example, favabay.com, and this favabay.com does not open. Your browser keeps loading again and again and again for 1 second, 10 seconds, 1 minute, 2 minutes, 5 minutes, 10 minutes, 1 hour, loading. It does not give you an error, a specific error reply. No, but keeps making you waiting. Sometimes it tells you it is not available. It tells you not available, but no error, only it's not available. This is a denial of service attack that has been happening on that website, favabay.com. As for an example. Denial of service, literally said, denial of service means there is no service. The service is denied, not deleted, not changed, not modified. It's denied. You do not have the right to access. And here it is not a context of no right, but no, because you have to wait. You have to wait. The attack goes behind making the service be busy. So any legitimate request will be actually put into a waiting list. Any legitimate request will be put into a waiting list. So wait. How it is happening? Actually, an attacker would attack a service provider using millions of requests, not only millions, trillions of requests. It's a huge number of requests. Keeping requesting, and the level that the web server or the service provider will be stuck. He did not finish the requests received from the attacker. He did not finish the requests coming from the attacker. He just trying to finish the requests come from the attacker, replying the attacker. The list of the requests, they are enormous. Thus, he is not able to reply to the legitimate requests. Thus, he is not able to reply. Thus, the denial of service happens. This is an example only, the SYNFLOOD attack. Refer to the book, please. Refer to the book for this visualization, the SYNFLOOD attack. Okay. I said an attacker attacks a service provider by sending enormous number of requests. Attacker and victim. Okay. How it happens if actually we are talking about an attacker using list of compromised devices, like in here. This is an attacker and this is a service provider. The attacker will use a list of compromised devices to request. All of them, they are requesting what the attacker is willing to do. We are talking about distributed denial of service. Distributed DOS. DOS, denial of service. DDoS, it is a distributed denial of service. Refer to the book for clarification of the distributed attack, visually speaking. Yeah. The attack usually is one, which is a service provider. And in the context of the DDoS, all of the machines, they are acting according to the attacker's will. They are all requesting. Before I continue, we were discussing the backdoor earlier, and we said the backdoor, it's a sort of a computer program that gets into a device without consent, and it behaves in an obscure way. Okay, the computer where the backdoor is, it is nominated Zoombie. the computer, the compromised device, the compromised computer, where it has a backdoor, it is named Zoombie. The Zoombie is a computer with a backdoor. It's a compromised device, Zoombie. A botnet, net. Bot is a shortcut for robot. A Zoombie, it is a compromised device. It would allow remote access and it would act according to the will of the attacker. So it is a robot. It is acting autonomously according to the will of the attacker. So it is a kind of a robot, the Zoombie. The list of zombies, they are created in a network because they are belonging to the same attacker. They are in the same network. So botnet. List of zombies belonging to the same attacker. Create a botnet. شبكة روبوتات. Real case related to the DDoS impact, whatever, refer to the book, please, for more readings. Any questions at this level, please?
No, Mr.
Okay, great. The denial of service, it is not only a web-based or only like the example we given here, the SIM flood attack. Not only that, but there are so many versions talking about the DOS attack. Amongst of them, the wireless DOS. You have a router at home, and you are trying to get in to the internet using your mobile or your laptop. No connection. Try again, no connection. You restart your computer or your mobile, and still no connection. You cannot. Try, and then after fail. Try, and then after failed. Usually there is a signal, but you cannot connect. Why? Because among the reasons here that the wireless DOS has been happened on your device. Your device is being equipped, is being busy, connected and occupied by a strong signal sent by an attacker's device. Maybe your neighbor, maybe an attacker in your likelihood, or something like that. Because wireless devices and commercial ones specifically, they have a limited number of connectivities, 10 or 15 or 20 maybe. The memory for processing the requests and the capacity to process the requests is very short, maybe 10 members only to connect at the same time. So if the attacker sends a strong signal to this wireless device, this device is usually busy with this strong signal. So any legitimate request, it will find, no, I'm busy, I cannot, I'm busy, I cannot, and so on. Usually I'm busy. Why? Because the attacker has been successfully communicating with a strong signal with the wireless device. So the wireless DOS has happened, wirelessly attacked. Nothing destroyed here. Only it is busy. In the same regard, it is not only to use a strong signal to succeed in doing a wireless DOS. It is not only, but one of the attacks is to use a strong signal. Powerful device that sends strong signal. It would occupy the network device, the wireless network device. Another technique to do also wireless DOS is by sending a disassociation frame. How? An attacker will mimic that he is a client by doing a privilege escalation or by doing a network device, a network redirect, or a device redirect. We defined that last class, network redirect or device redirect. We defined that last class. And he sends this association frame request to the network device, to the wireless network device, saying that I want to get disconnected. This association frame, actually, if I ask you now, if I want you to disconnect your mobile, from the internet, what you'll do? You'll click the link, the icon, and then after you choose disconnect. What happens? There is a message sent to the wireless provider to disconnect you. That message is named disassociation frame. If the attacker succeeds in mimicking your identity by doing, for example, device redirect. So, if he sends this association frame to the wireless device will disconnect you, not the attacker. Why? Because the attacker used your ID, your identity. So this way, this is another category of the wireless, let's say, attack, and here specifically wireless DOS. Any questions, please? This association frame. Mustafa, any questions? Mustafa, any questions?
No, thank you, Mr.
Ali, any questions? Hamid Ali, are you with me? Are you following or not? Let's continue. Let's continue. At the beginning of this chapter, we defined the sniffers. The sniffer is used by an attacker to sniff a flow. A sniffer is used by an attacker to sniff a flow, a network flow. We saw the protocol analyzer as an example. Here we are defining something new, which is the spoofer. And the sniffer, at that time, we said that it is a sort of an eavesdropping tool. It would actually see what is happening, what are the data communicated, only in a static way. It means just to visualize, to have a copy maybe, but only to visualize. There will be no modification. This is a sniffer role. Here we are defining the same context that will be actually a network flow monitoring, but this is with a malicious intent, in the sense of there will be a malicious intention to change the flow, to hack the password, to see what is happening, and do a network redirect or device redirect, something like that. There will be an active attack here. There will be some changes. So we are talking about a spoofing activity, not sniffing activity. So it's the same context, is to intercept the flow and to visualize what's there, but with modifications, either to do a network redirect or a device redirect, or to change the flow content itself. There will be an active attack, so spoofing, not sniffing. Literally said here. Yeah, in all cases, whether we are talking about an active or passive attack, whether we are talking about sniffing or spoofing, a man in the middle actually attack is happening. So in all cases, a man in the middle, meet is happening. A man in the middle attack is happening. What does it mean? It means there are communicating parties A and B, and somebody is getting in between without consent. Hey, it does not mean this attacker here does not tell the B, hey B, I'm attacking you, or hey you, hey computer A, I'm attacking you. No. It is without giving any hint. It would enter the flow in between, and we saw the techniques. If it is a passive attack, so we're talking about sniffing. If it is an active attack, so we are talking about spoofing. And it is a very common network attack or network vulnerability. The replay attack. This is a very actually dangerous attack, and it is specific to certain frameworks or certain work areas. We are talking about the use of communicated media for reuse again in the future. Mainly we talk about wireless signals, because if it is in a wire-based communication scenario, it will not be so much fruitful or useful in future time, because it has to be used in real time when we talk about wire-based. But for the wireless communication scenarios, it can be fruitful in future. Why? Because wireless communicated media, usually the frames, they are communicated with unique ID every time. Unique ID is communicated every time. Means any wireless signal transmitted is usually unique. What does it mean? Means what it has been sent today, it is not the same ID tomorrow. It's not the same ID after tomorrow, and so on. I give the example of the car key. The car key. Whenever you try to open your car using your wireless key, you press the button, the car opens. Or you press the button again, the car closes. So what is it? It's a wireless signal has been submitted, and this wireless signal is unique. Unique means the car will receive a different ID every time. If an attacker captures that signal and does not let it go to the car from your key, so the attacker can use it again in future time, because if he sends it to the car will see that his new key and his new ID, it will open the car. So replay attack. So a signal to be captured by an attacker to be used in a future time. It has the same characteristics, but with a unique ID. To be used in future time. To be used in future time. I'm going to stop at this level. Unless you hear your name, please say yes. We'll talk about the in semester and this assignment also.